Yes.
Yeah,
It is
yeah, what is your good name, sir?
KSVS Rao. I am from Gulbarga, Kendriya Vidyalaya. It is an age-old question. Is light a particle or wave? So in the very beginning, to begin with, we have to commence with Sir Isaac Newton. He is firmly of the opinion that light is in the form of particles. Because of the particles, he could explain both reflection and refraction clearly. And then his contemporary, this gentleman is Huygens, a Dutch physicist, who has propounded the theory of wave, but he could not convince the people so easily because he said that a medium that is required to propagate the light, but he could not give the proper explanation, and he says that neither we can feel the ether nor we can see it. So that's why people have simply rejected his theory and it was dumped for 1 century. Now if you look at this gentleman, this is Thomas Young, who is the follower of Huygens, has shown the double slit experiment, and double slit experiment he took 2 slits and the light is allowed to pass through, and for his surprise it was not simply 2 patches of light, it was the combination of dark, bright, etc. Now it is very surprised that light plus light becomes dark. So that is the main thing for him, and now it can be demonstrated. So you can see so it is seen that not only 2 patches of light is there, but it is the combination of dark and bright patches of light is there. So sometimes the light plus light will give us darkness. This is really a surprising thing, and it is completely in agreement with the wave theory physicists. In the same time, Foucault has proved that Newton was wrong, because Newton was taking the idea of attraction in the case of refraction, and he has taken the repulsion in the case of reflection. How a medium can act both repulsive and attractive forces between the two. So that's why Foucault could prove that the speed of light in water is lesser than that of speed of light in vacuum. So again Newton was defeated in this time also. Next comes the diffraction effect, which has also helped the wave theory physicists to move forward. Then once this argument was there, so wave theory physicists have completely dominated the particle theory physics. But the story was not ended at the time. Before that, let me tell you, we can explain the wave theory with a simple low-cost teaching aid. This wave theory and particle theory can explain some of the concepts. So now you can see in the upper part of it, this is wave and this is particle. So reflection could be proved by both the two. Similarly, refraction. So the 3 rays which are parallel to the principal axis, after refracting, they were meeting at a particular point which is called focus. Now this is a different kind of lens, that is concave lens. Here the 3 parallel lines will be diverged. Now if you observe the refraction through prism, you can see that this ray is coming and hitting this prism, and it is undergoing the refraction, and then finally it is emergent ray. So similarly one can show the diffraction. So diffraction is a phenomenon when light is being obstructed by a particle of size of wavelength, then it bends at the corners. So now once the wave theory physicists have dominated over the Newtonian particle theory physics, then comes the Einstein, who was awarded Nobel Prize for explaining the photoelectric effect. Photoelectric effect can be explained only with the help of particle theory. Let me show it to you. This is a phosphorus sheet, and these are the 2 different lights. So this is green laser light, and if you compare the intensity, this intensity of this violet are just nearer to indigo light. It's very small when compared to this. Now you see, you are not observing anything. Now if I keep You can see this effect. So this confirms that particle theory is only correct and wave theory is wrong. So wave theory physicists could not give the proper explanation for the photoelectric effect. So then again the age old question remained as a question only. So then finally, to pacify those two, both the team of wave theory physicists as well as the particle theory physicists, the de Broglie, he has come to a conclusion that light sometimes behaves like particles and sometimes behaves like waves. And in the Solvay's conference, many physicists have assembled there, and they have had a lot of discussion on wave and particle theory. And then finally they came to a conclusion. In the morning we talk that light is in the form of particles, and at the same time in the evening we talk that light in the form of waves. So now the final conclusion is that de Broglie could prove that any moving particle can produce waves. Even we can also produce waves, but the wavelength lambda is equal to h by p, which is h by mv. As the mass of the object is more, the wavelength is very small, which cannot be observed by the naked eye. So even your compound microscope, electron microscope, can work only with the diffraction, again which is wave theory. So in that way, light behaves like both particle as well as wave, and then it has got dual nature. So that's why